Alright, we're going to get started. Today we're going to be talking about solving systems of equations using the substitution method. So let's get started. So if we have the equation or the system of equations y equals x plus 2 and x plus y equals 6, and we're going to solve this using the substitution method, well, as the word substitute would indicate, we're going to substitute. In fact, if y is equal to x plus 2, then we can substitute x plus 2 anytime we see a y. So if you look in the other equation, we can substitute x plus 2 for y there. And so that's what we're going to do. We're replacing y with x plus 2. We can now solve this equation for x, and we get x equals 2 when we do that. Well, remember, most of the time when we solve a system of equations, we're going to get a point. So our point has an x value of 2. Now to find the y value, we want to use our equation that's been solved for y. So let's do that. We've got y equals x plus 2, and we know that x is 2. So y will equal 4 when x equals 2. Which means our solution is the point 2, 4. Now again, we can use our we can always check our answers anytime we're in this situation. So if I plug in 2 for x and 4 for y, it should make both equations true. So in the first equation, again I'm replacing y with 4 and x with 2, and notice that that is going to work. It makes the equation true. In the second equation, if we take x and y, x plus y, that'd be 2 plus 4, that does equal 6, and so that will also check. So we can always check our answers when we're solving a system of equations. I highly recommend that you do that. Let's move on to the next problem. We got 3x plus 5y equals 3, and x is equal to 8 minus 4y. So again, one of the equations is solved for x. X is equal to 8 minus 4y. So I can replace x anywhere else with 8 minus 4y. Well, the other equation, we're going to go ahead and replace the x there with 8 minus 4y. Notice now we can solve for y. And we end up getting y equals 3 when we do that. And now I understand I'm going quickly here. You're certainly able to stop the recording at any time you need to. We know that y is 3, so in our point, the solution is going to have a y value of 3. And we can go back to our equation with the x in it. And we're going to replace y with 3 and figure out what x equals. So when we do that, we do get negative 4. And so that's our solution. And again, you can check your answer, but I won't be doing that just to save some time. Let's move on to the next problem. Alright, so we got 9x minus 2y equals 3, and negative 3x plus y equals negative 6. Now notice this problem's a little different. We don't have either of the equations solved for x or y. But if you look at the second equation here, it would be pretty easy to solve for y. So we're going to do that. So now that we solved the second equation for y, we can do a substitution into the first equation. So we're going to replace the y in the first equation with 3x minus 6. So let's do that. Notice this is an equation in x that we can solve for x. And if you do that, you should get x equals negative 3. Now again, we've got half the answer here. We know x is negative 3. Again, we can go back to our equation that's solved for y, and we'll use that to find what y is equal to. And you should get negative 15. And so that's our solution there. Let's move on to the next problem. Now this one's going to be a little bit harder to solve for y. What you're really looking for is a 1x or a 1y somewhere. And sometimes you have more than one option. We could solve for any variable, but it may not be a good choice. Notice here we have a negative 1y. So let's solve the first equation for y. Alright, so we'll subtract 3x on both sides. We'll multiply each side by negative 1. And so we get y equals 3x minus 14. So we just rearranged the first equation and we got that y is equal to 3x minus 14. And so that's what we're going to substitute in to the other equation. We're going to replace y with 3x minus 14. So let's do that. So now we can solve for x. Now something strange is going to happen here. Notice we have a 6x. Whoops, let's do something a little different. We have a 6x and a minus 6x. That adds up to 0. So we're going to be left with 28 equals 10, which is a false statement. Anytime you're solving an equation and you get a false statement, you're going to have no solution. In fact, we talked about graphing, and if you were to graph these two lines, you would find that they're parallel, and that's why there's no common solution. Let's move on to our last example. So here you have a is equal to 6 minus 2b. Let's substitute for a in the first equation. And when we do that, notice we get 6 equals 6. Or we can even subtract 6 on both sides. So anytime we get a statement like this, what's happened here is everything has fallen out, and the reason why is because they're the same equation. That's why we end up with 0 equals 0 or 6 equals 6. Anytime this happens, we have infinitely many solutions. What this means is these are the same line. In fact, if you look at the first equation, if you solve it for a, then you get the second equation. So they are the same equation. All right, and that's the end of this lesson.